Hi everyone, welcome back to my channel. So today I am doing another coding tutorial. I asked a few of you what topics you were still shaky on, and as a beginner, what topics were most confusing for you. A lot of you said recursion, so today I'm going to be focusing on recursive functions, and hopefully I will be able to explain a little bit more to you about what recursion actually is, and at the end I will be showing you two examples, one with factorial numbers and one with Fibonacci series. Recursion is a method of solving a problem in computer science where the solution to a specific problem will rely on the other solutions of smaller instances of that problem. And I know that sounds like a lot of words and you're probably like, what in the world are you talking about? But I will give you a little example right now. So if I have a function where I give an input number and I want to print all the numbers leading up to that one, so let's say I give my function the number 10. I want to print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I can do is say, if my number is not 0, print it out. And then I can say, call this function again, but sending in my number minus 1. So you can see how the overall solution will be all of the numbers 1 through 10 printed out, but in order to get that solution, we had to continuously call this function and get one solution at a time. So the first time we said, here's 10, if it's not 0, print it out. And then we can say, send in 10 minus 1, so call this function again, but with a 9, and it'll go into the function. Is it less than or equal to 0? No, it will print it out and it'll keep doing that again with the minus 1, so we would get 8 and so on until we get down to 1. And then we get, is 1 less than or equal to 0? No, print it out. Then we send it back in through the loop, then we say 1 minus 1, so we get 0. And then the function will check, is 0 less than or equal to 0? It is, so then it will stop. So then you can see that we have our numbers 1 through 10 printed out, and that was the one solution we wanted at the end. And like I said, the recursive solution depends on all of these smaller instances and their own solutions. So I know what you're probably thinking. Why don't we just use a for loop if we want to print out 1 through 10? Like we could do that in 2 lines. Well, this is just a small example for, a method that can be used to solve really hard problems and really condense your runtime and the efficiency of your algorithm. So right now, of course, we're going to be doing examples that, yes, could be solved iteratively, but the basics of recursion is what we're trying to learn. So try and stick with me here. Now that you have an idea of what recursion is, don't worry if you're still lost. I'm going to keep explaining. So a recursive function is a function that keeps calling itself. It will keep referencing itself. So it is comprised of 2 parts, the base case and the recursive call. In the example I just gave, the base case was, is my number less than or equal to 0? Because if it is, I want to stop printing. This is what helps you avoid infinite loops. If you don't tell your function what the base case is, it'll keep printing forever. The base case can really vary. It depends on the function and what you want your function to do. For us, we didn't want to print that 0. So your base case is so important. Always make sure and double check that you have it. The recursive call is the part of the function that will call itself. So in our solution, we had print the number, check the base case. If it's not in the base case, recursive call. So our recursive call was call the function again, but with a modified input. Normally the modified input will just be like, n minus 1 or the string length minus 1, things like that. So you bring in that modified input and it'll keep calling itself until it hits that base case. But every time you're slightly changing the function. So it's not the same function call every time. It's slightly changed with that input. And that's how you're gonna get your recursive solution. So you want to use recursion when your problem can be divided up into steps, or when the result of one step can be used in the previous step. If all the solutions to the problems solve the overall problem. When you're making your recursive function, you want to make sure you have these 4 things: a base case, a recursive call, a guaranteed smaller problem as a result of your recursive call, and you want to make sure that your base case is actually reachable. So I'm going to explain one more example before I get into the actual coding portion. This example was sourced from freecodebootcamps.com. I will have them linked down below, as well as the article that I'm referencing. So I think it's really important to see the diagrams that they have, because you can see how an iterative approach can actually be solved easier with a recursive approach. So their example is kind of a Russian doll scenario. So if you don't know what a Russian doll is, it's basically a doll that once you open it, there's another doll inside, and another one, and so on. So their example says we have one giant box, and when you open that box, there could either be boxes or a key. If there's boxes, you need to keep looking through them until you find that key. Once you find a box with a key, you know you're done. So here are the diagrams that they have explaining this. The iterative approach is making a pile of your boxes to look through. While the pile isn't empty, you're going to grab a box, and once you have that box, if you find the key, you know you're done. Otherwise, if you find a box, add it to the pile of boxes, and then you're going to go back to the pile and keep repeating until you find the key. The recursive solution can be solved in literally 2 steps. So you say, go through every item in the box. If you find a key, you're done. Otherwise, you have found a box, so you know to go back up and just go through every item again in that new box. So I will have this article linked down below, and feel free to read through it. I think it's a great example to understand the basics of recursion and why recursion can actually simplify a certain problem. Okay, so now I'm going to start with the coding portion of the video, and we're going to start with factorial numbers first. So a factorial in math is the product of all the numbers less than or equal to n. And so what that means is if I give you factorial of 5, that means I want to have 5 times 4 times 3 times 2 times 1. So 4 factorial is actually comprised of 4 other factorial cases. So in this diagram, you can see 4 factorial, 3 factorial, 2 factorial, and 1 factorial, as well as 0, which is your base case. So then this is where recursion would come in handy. We can say once we've hit 0, we're going to return 1, and we're going to multiply our factorial times what we returned. So we do 1 times 1. We take that, that's our new return statement. We say factorial 2 is 2 times whatever we just returned, which I said is 1. So we do 2 times 1, and we get 2. And then once we get to the 4 factorial, we say we want to do 4 times whatever we just returned, which is 4 times 6, and we end up with 24. So I'm going to code this, and I'm going to show you each step and how it translates to code. So now I'm on the Geeks for Geeks website, and I will have this link down below. I modified their factorial function just a little bit. So you can see we have our include IOStream, using namespace std, and then we have our function. We can see that it's of type integer, so we know we're going to return a number, and we are also giving it an integer, so we know that we're dealing with numbers here. We say in our function, if n equals 0, return 1. So this is their base case. This is from our diagram right here. If we get 0, if we're at 0, we're going to return 1. So you can see if I give it the number 4, 4 is not equal to 0. So if I do not enter this base case, if I do not go to this return 1 statement, what I'm going to do is I'm going to do n times factorial n minus 1. This return does not mean return out of the function completely. What it's saying is go until our base case is met. Once our base case is met, that's what will start up this pattern that you can see in the diagram. We've hit our base case, and we're going to do the repetition of returning and computing. So, to walk through that, we would say 4 times factorial of 4 minus 1. So we're saying 3 right here. So we're saying 4 times factorial of 4 minus 1. So there's our modified input. We would call the function again, and instead of having 4 right here, it basically has a 3. It'll say, is 3 equal to 0? No. And it'll keep doing that until it hits 1, and then we get 1 minus 1, we get 0. So then once we're right here, it'll say 0. If n is equal to 0, which it is, we will return 1. But when we're returning right there, we're not actually just returning the number 1. We are going back and we're doing pattern right here. So it'll compute itself, and then it'll give you the actual solution once it pops out. So we would return 1, how I explained this earlier. We would take the solution to that factorial and then it'll add them all up. So you can see that our main function is saying int num is 4. And then I'm going to print out the factorial. I'm going to send in 4. So I should get 24 out. When I hit the compile button, you can see we get factorial is 24. So you can see how this solution depends on the solutions of these sub problems here. And so that's why we use recursion when we're doing factorial numbers. Okay, so now that you've seen factorial numbers, we're going to get into something a little bit harder, which is Fibonacci numbers. So the Fibonacci sequence is a sequence of numbers where the number that you're at depends on the numbers that came before it. But basically, the number is the sum of the two preceding ones before it, starting from 1 and 0. So it's kind of like the factorial, but often people get a little scared of it, so don't worry, I will break it down. It's not even that many lines of code. Okay, so I am again on the Geeks for Geeks website. I will have this link down below. Here is the Fibonacci sequence using recursion. So we have our regular include statement and our using namespace std. But then here we have our recursive function called int fib, and we give it an input of int n. So we know we're dealing with integers and only numbers. Here in the main, I pass in int 4, just like last time when we were doing factorials, sticking with the number 4. And then it'll receive that as an input. It'll say if n is less than or equal to 1, which 4 is not, so it will not perform the base case. But our base case says return n. That'll be helpful for later. But since we have 4, we say return the function call with n minus 1 plus n minus 2. So our number is actually equal to the two numbers before it summed together. So if you look at the Fibonacci sequence that I have on the screen, we can see that the numbers are 1, 1, 2, 3. And that's because 1 plus 1 equals 2, and then 2 plus 1 is equal to 3. So because in computer science we count with 0, 1, 2, 3, that's actually 4. So our fourth number is this 3. So to further understand our program, here is a Fibonacci tree. If we look at the Fibonacci of 4, we can see we do the n minus 1 and n minus 2. We get Fibonacci of 3 and Fibonacci of 2. Then within those, because they're not less than or equal to 1, we keep going. We do the n minus 1 and n minus 2. If you can see on the left-hand side, the Fibonacci of 3 stops on the right-hand side where it says fib of 1, because that's where our base case was met. On the other hand, it keeps going, and then it stops once it gets fib of 1 and fib of 0. So then we also do that with the right-hand side, where we do our fib of 2, and this comes from that original statement of doing fib of n minus 2. So then we solve all of that, and at the end you can see whenever we have a fib of 1, that's what the number is going to be. So we have 3 fibs of 1. So that means that the Fibonacci number at the fourth index is the number 3. If you look at this Fibonacci of 5 tree, it's a bit larger, but it's basically that same thing where it checks to see if it's less than or equal to 0, and if it's not, it'll keep dividing them. So at the end of all of our division, we have 5 Fibonacci's of 1. And like we had in our program, we said return fib minus 1 plus fib minus 2. So what we do is we take the left-hand side of the tree plus the right-hand side of the tree, and anytime there's a 1, we add those together. So we know that the Fibonacci number at the 5th index is 5, because we have 5 ones. And every time we do that return statement, we're doing a recursive call to keep adding them together. So I hope this helped you understand recursion a little bit better. Just know that the most important thing about a recursive function is the base case and the recursive call. That's really all there is to it. And a recursive function is something that keeps referencing itself. And you use it when the solution to the subproblems will help you get to the overall solution. You might need to keep reading some more about this because it's not something you can learn in just one video. I will have a bunch of links to different articles as well as the code that I used down below. If you have any more questions or suggestions, definitely comment them or DM me on Instagram. So yeah, thank you so much for watching, and I will see you guys in the next one. Bye guys.